All right, so this is SIG Auth on May 3rd. You should be seeing the agenda now, and you can see what we're going to be talking about. We're going to be talking about the individual identity in Docker Swarm, which will be very useful to us if we try to identify pods and what they're trying to access. And then Jordan is going to talk about the scoped Cubelet API access. I don't know of any other designs that are of note. If someone has one or a pull request that we need to talk about, you can go ahead and add it to the agenda while we're talking, and we will circle back to it. For now, is Ying Li here? Really hoping.
So this was a thread that was where we had people from Docker Swarm who are going to come and give a presentation on sort of the security model and about secrets in Docker Swarm. This is also their first time, I think, using Zoom, so we might want to give them a few minutes.
Okay. If we see them pop on or ask in Slack, be sure. Let me see if they're in Slack now. I'm trying to figure out how to join here. Well, be sure to get them in. I guess we will move on with Jordan then and let him go first. I don't suppose you happen to know, can you ping him directly, Eric? Ying Li?
I don't have anything.
Okay.
Yeah.
All right. All right, Jordan, you want to tell us what's awesome about scoped Cubelet access?
Sure. So you can jump over to the GitHub pull if you want to follow along, but basically we are taking the access that nodes currently have and trying to partition the mutations that they're allowed to do to nodes and pods so that they only get to mutate themselves and the pods that are scheduled to them. And then we also want to limit their ability to read secrets and config maps in particular to just the ones required by pods that are scheduled to them. So this is intended to let you divide up your cluster so that you have some nodes that are running less trustworthy workloads, and if those workloads escape and compromise their node, they should not be able to then access secrets and config maps intended for other nodes, and they should not be able to modify pods scheduled to other nodes, and they should not be able to create pods which would then be scheduled to other nodes. So it's limiting the impact of a compromised node to itself and workloads that were running on that node. And so I kind of laid out the two stages where we would accomplish this subdivision. For those who aren't familiar, and I'm actually going through now and kind of making updates to this in response to some comments. For those who aren't familiar, we have an authorization phase, which all API requests go through. So that's a nice point where we can control all requests, but the downside is we don't have all the information about the request. We only have the headers and URL. So in particular, the contents of the request body has not been parsed at this point. And so we can, in broad terms, say, yes, you are allowed to create a pod, but we can't decide if you're allowed to create this particular pod based on some attribute because that's inside the request body. And so you see in this proposal enforcing some things at the authorization point, and then later enforcing some things with an admission plugin. And admission plugins, at that point, we have parsed the request and we have the full API object, and so we can look at particular fields and make decisions based on those fields. So that's why this is kind of divided into two enforcement phases. And I laid out for the node authorizer what we would enforce there, and then for the node admission plugin what we would enforce there. I'm also kind of putting together a future work or future improvements section at the end. There were some questions about, well, nodes look at all sorts of things. They look at persistent volume and persistent volume claims and other resources like that. Can we enforce gets on all of them based on like a relationship between the object and the pod and the node? And the answer is probably not right now, just based on time constraints. There should not be sensitive information in those API objects. To my knowledge, there is not sensitive information in those API objects. And so the most important things to do first are protecting config maps and secrets and protecting the mutations that a node can make that would affect other nodes, so nodes in pods. So if we want to expand this in the future, that is certainly something that we can look at, but we want to get this initial version in to protect the issues we know exist. So
wouldn't visibility to persistent volume allow me to find a node and on the correct network? Wouldn't it allow me to mount in a persistent volume based on information that I can only get from that persistent volume and have access to it?
It should not. So if there are credentials needed to mount a persistent volume, those are supposed to be referenced within a secret. So visibility of persistent volumes is not supposed to be escalating.
Well, what I'm saying is that you wouldn't know what it is you had to mount unless you were able to look at the persistent volume that belongs to some other pod. I guess I agree it's a secondary target compared to the rest, but I'm actually creative and find a way to use the knowledge in a persistent volume to be able to get at data that I wouldn't otherwise know where it was local.
Yeah, it's certainly, I can certainly see a desire to limit it, but I think that's a secondary step. And we have, once this is implemented, we have a place to put checks like that and control checks like that. So we have a framework where we can add those restrictions. So I mean, this is part of what the proposal is for, to see if everyone feels strongly that we should do this now, or if we should prioritize, doing what we can step at a time. So if you have strong feelings, feel free to jump in on the proposal and make comments there.
Can whoever is typing please mute? Sorry. Or.
So I have a follow-up question. I think that's one example of, like, there's some stuff that could be part of this that either maybe is currently planned not to be part of it. It would be nice to include in the proposal what we know we could potentially do, even if they're part of, a phase 5 in the farthest future. And I think so, for example, should a kubelet be able to see all pods in the system, or can it only see pods that are scheduled on it? Same thing with the persistent volumes. What are all of those other objects? We know we need to do secrets and such, but those are necessary. What is the sufficient set?
Sure, yeah.
I think long-term, getting to the point where we actually have some sort of audit where we're sure that it's only the things that the pod needs, so it's a whitelist instead of blacklist type of thing, might be a good place to go. With the thinking of it, and it'll take time to get there, obviously. Yeah,
building the relationship graph from the node out to all objects is fun.
Educational, I'd imagine.
So
yeah,
how do static pods work? Because that's essentially creating a new pod.
So that's a good question, actually. So right now, static pods are not allowed to reference secrets and never have been. And so it was actually my understanding that they were not supposed to reference any API objects. They were supposed to be statically defined, because they are able to run on a node that does not have a connection to an API. I don't think other types of API references are actually enforced. So I think you could set up a static pod that referenced a config map or a persistent volume claim. For purposes of subdivision with this admission plugin, we will not allow that. So if you want to if you want to limit a node to only reference things that its pods reference, then you obviously can't let it just then go create a pod that references anything it wants. And so
okay, so that's something that the node admission controller does.
It will, yes.
Okay, so yeah, add that to the list.
Yep.
Yeah, and I think to be clear, no one's proposing that that must all be done in one big group. It's just I think breaking it up, the authorizer and admission part all makes sense to me. It'd just be nice to know, how does this fit in within the larger scope planned work to get us to sufficiency?
So, and another stupid question, static pods, do they always show up in Cube System? What namespace do they show up in?
You can actually choose.
I think you can put a namespace on the pod in the pod spec.
Okay. All right.
It makes me sad in so many ways.
It might be. I mean, so one idea here, and this would actually move it to the authorizer, if there was a special namespace called Cube Static or something like that, static pods would only show up there, and then the scheduler would know not to look at that thing. Then essentially that's a write-only sort of place, and that might be a way to sort of move this earlier. But that's a more disruptive change, obviously.
Yeah, you still need the admission for creation. So on creation, you need to know whether the node, whether it even is a mirror pod, and because that's in the body of the request. So we already need to be looking at the body.
Okay. Well, I mean, you could set up the system so that only nodes can create stuff in that namespace and nobody else can. And so that namespace is ignored by the scheduler, and that could all be authorizer.
I see. Yeah. So the thing is, we have kubelets doing these things today, and because we have to have back compat 2 releases,
yeah.
I would like
too many moving changes. Yeah.
An admission plugin that I can run against well-behaved kubelets today, and ones that aren't overstepping their bounds will be perfectly in bounds. So
now, is there the assumption that to use this effectively, each kubelet needs a unique identity, a unique cert?
Yes. So one of the first things we talk about is node identification. And if we can identify a node as an individual node, then we start subdividing its access. If we can't, then you've given your node an identity that doesn't let us subdivide it.
It might be, I think, more feature requests. It might be great to have an option on, probably this would be on the API server that says every node must have a unique ID, otherwise it can't do anything. To essentially be able to flip your cluster into a node where you must be able to identify nodes uniquely.
Yeah, so I would consider that like a strict mode. So
yeah.
If you try to do anything and we say, oh, we see you're a node, but we can't actually figure out which node you are. And right now we're saying, well, you fall back to the broad access because we have to for compatibility. But I would like a strict mode that says, if we think you're a node, but we don't know which node, sorry, you have to tell us. So reject it. But that would not be the default. That would be like a strict mode or something like that.
Yeah, since this authorizer wouldn't say okay, it would just fall through to RBAC in that case.
Well, so RBAC is interesting. So if we're going to switch to a per node authorizer, RBAC will stop having opinions about nodes. This will be a special authorizer for nodes, just like we have a special authorizer for the API server talking back to itself. I mean, we want to avoid special cases, but I'm comfortable in saying that every useful Kubernetes cluster will have nodes. So if you're going to have a bespoke authorizer, having it on nodes for something that has like really complex transitive relationships doesn't seem an awful thing to do it on.
Right, but an authorizer chain, if one authorizer doesn't recognize it, the next one will allow it, or can allow it, rather.
It can, that's correct.
Yeah, so I've brought it down here just so that everyone can see what we're proposing is that we would no longer bind that cluster role. And so if you have an environment where you do not give your kubelets the expected names, you'll need to rebind that RBAC role to get access.
So you're saying strict mode by default. Strict mode by default gets interesting with the admission plugin. I guess the admission plugin is purely optional, and if it can't do anything, if you haven't segmented out your nodes, then enabling it and having it ignore them is probably not great. All right, let me think about that, whether we want to do strict mode by default. And the way you would opt out is just give your nodes permission some other way, which you must already be doing, and not use this as admission plugin.
Yeah, because it is a configurable chain.
That's true. All right, I'll think about that and update the proposal.
So, I mean, there's going to be some sticky practicalities around node naming because it's kind of a mess.
Mm-hmm. I comfort myself with the knowledge that kubelets do have to know which node name they are because they are responsible for creating it and updating the status on it. And so there is no kubelet that does not know which node it is supposed to be.
Yeah, I'm just thinking of like on AWS, there's the cloud provider in the kubelet like munges the node name to make it fully qualified so that DNS now works for that host name. And it's not clear how that munging is going to be working outside if you're creating the certificates before you launch the kubelet. So
the node name no longer has to be DNS resolvable. We fixed that in 1.5.
I know, but I think that the default in the kubelet on AWS is to still munch the node name.
Okay, well, it matters.
I'm just saying, like, there's going to be some sticky practicalities here.
Yep.
I think the idea was also that we would pair this with all the work that's been going into the TLS bootstrapping, because that will give your kubelets the exact correct certificate that they need to act as that node. So hopefully, as that work progresses and as more distributions switch over to TLS bootstrapping, then.
But just to be clear, I think, as I've talked to customers, there's a lot of customers that don't want to use any sort of certificate authority stuff that's built into Kubernetes, and they want to actually create and manage certificates all themselves. Mm-hmm. And so I think it's important that not only do we support this in the TLS bootstrapping, but we get good documentation in terms of like, what does like a cert that's going to work with this system look like? And just, and it could just be as simple as like the common name has to be broken up like this, and this has to match the node object. And if it doesn't match your SOL, right? I mean, like that's probably what it's going to be, but like we should at least document that super clearly.
Yeah, agreed.
All right, well, that's all I had.
All right, did we manage to pick up Yingli?
I followed up on that email thread, but haven't got a reply. So I think we'll assume that it's not happening today. Apologies for anybody who showed up specifically for that.
I was looking forward to that. All right. So as promised, looping back up, someone linked in a pull request for certificate rotation. I'm going to assume it was Jacob. Does he want to talk about it?
Oh, that was me. This is more just one of the sort of gaps in the current TLS bootstrapping is that the node won't request a serving cert. It will only request a TLS or a client cert. The reason I linked the PR is because I think it explores a little bit about, it exposes a little bit about the current approval process for nodes going through TLS. TLS bootstrapping, the state of the art currently seems like it's enabled that one flag on your controller that is like approve all certs for this particular group. But obviously you want different types of policies for like, okay, if I'm using a bootstrapping token to request a certificate, yeah, maybe I do some initial thing, but there is a different one if a kubelet has an established client cert and wants to request a paired serving cert. So I guess the conversation here is the possibility of expanding that approver built into the controller master or the controller to start being a little bit more smart than just, hey, you're part of this group and therefore we approve you.
So there were always multiple types of approvals that we were going to want to have. The flag was just sort of a quick and dirty experimental, it's in the name, type of flag. So the types of approvals we have are the bootstrap approval, where you can request a client cert for any node. So that's where you're bootstrapping a bunch of nodes from one shared credential. Then there's the renew my client certificate type of approval, where you ask for a client certificate that matches your current user. So a kubelet could get a short-lived client cert, like it's good for a day, and just renew it every 12 hours. And then the final one is what the one this is talking about, where a kubelet asks for a serving cert that matches the node that it's the client for.
Now, we had always said before that we were going to try to manage those with different controllers, as I recall it.
Manage the approvals?
Yeah, that the expectation was that we would not forever have an approve all flag, and that approval would be managed separately with some sort of check that could actually confirm that the kubelet had actually asked, right?
Right. So the different levels are either just granting the permission, like once you identify that a particular CSR is falls into one of those categories, you can either just approve that type of request to say any node can ask for a new client cert for itself, or you could go all the way to like attestation or TPM checks against the node, kind of out of band. I would love to see those. I haven't seen those getting built. I'm not sure if Mike has, and, but yeah, you have a variety of levels. Like how much due diligence do you want before you sign this thing? The first step I would want to do is have the permission-based check instead of a flag, just so you could grant it and then revoke it without restarting everything. So you could grant the bootstrap permission, and then once you were done bootstrapping your cluster, you could revoke that.
There's in place of TPMs, there's some metadata APIs in AWS.
Is someone talking? It sounded really quiet to me.
Yeah,
can you guys hear me?
That's better. Yeah.
So in place of TPMs in cloud, I know that AWS and GCP have other mechanisms of verifying node identity that we could, I guess, that would chain the trust of the kubelet onto the trust of the metadata servers in those environments. And I think that Justin and some people on my team have been looking into those as part of the admission for new nodes.
Does that feed into the public key that the kubelet uses to request the cert? So it's like a challenge against the public key, or is it something else?
So there's a couple ways on. There's a couple ideas that we've thrown around. One is to create a specific authorizer just for JWTs that we would receive from the metadata server, or the identity document that we would receive from the AWS metadata server. Just pass that as the initial bearer token. We can then authorize that with a specific node name and a group that is allowed according to the subject access review. That would be allowed. The group approver would allow it to approve the initial certificate. Does that make sense?
So, Mike, I think at least with AWS, the identity document is not really strong proof. It essentially says it's a bearer token saying it came from this machine. It's used a lot of times for verifying support with access to RPM repositories, that type of thing. So it's very easy for that to leak and move around. So it's not something that is sort of a one-time use or signed payload type of thing, unfortunately. So I think in my mind, that's best used as extra data to help verify this, but I don't think, I wouldn't consider it good enough proof in and of itself.
What is good proof? What is strong proof in AWS?
There isn't. I mean, like for me, like if you combined that with a Bootstrap token, right? So now you have something that's two pieces of information that by themselves aren't super strong, but if you require both of those, that actually makes a better case. I don't think there's a slam dunk here, to be clear, without. Like, it would be great if there was a way to actually say, here's a payload, hey, metadata server, please sign this with a thing that verifies that it came from this machine, and then we could use that as a one-use sort of challenge type of thing. But unfortunately, that doesn't exist.
I will have to look at that API and see if there's any way around it. But if we get both the identity document and the token from the metadata server, then there's not a lot of diversity in what needs to be breached.
I think the question is not so much as what needs to be breached, because if somebody gets access to the metadata server, they own the machine regardless to some degree, from a IAM role point of view. But I think there are situations where people will take that identity document, hand it out to others, and not realize that they're actually handing out something that can then be used to impersonate that machine. I don't think very many people use it in that mode where they consider it private, sensitive information.
So it would need to be scoped to this specific role as a Bootstrap or as a Bootstrap.
I'm just afraid, like, the machine comes up at Bootstraps, and then, like,
Sure.
It's worth digging into, and so I think it's worth considering a model where whatever this authorizer is, instead of actually having one piece of information, we have a way that we can sort of create some sort of score of, like, how much do we trust this based on a plurality of pieces of data that we can get.
Yes, and definitely it's going to be environment dependent.
Yeah.
I think
Joe, are you saying that the metadata server, nothing the metadata server gives should be accepted as proof of node identity?
I'm saying that anything that you get from the metadata server right now at Amazon people tend to pass that around to third parties, and then those third parties could then turn around and use it, right? So there's no sort of challenge response type of mechanism that you can use the metadata server for right now. So you can't create a unique token for one use right now.
So you're saying that people pass around their service account tokens from the metadata server?
They'll pass those to Amazon and the service account token, but you're not supposed to pass the service account tokens to anybody because that lets them impersonate you to Amazon. The thing in question here was the identity document.
I think the transitive thing is, right, something with access to the metadata server. That's what you have proof of. Or something that was passed something from access to the metadata server. Is that sufficient to guarantee that it is exactly the kubelet? And the answer may or may not be true. You can combine it with things like, can listen on a privileged system port, for example, or lots of other things. I think the meta point is we should be clear on what our requirements are, what we hope for from Amazon, from Google, from other cloud providers, from on-prem, and document those as, like, these are the user guide cases we need to meet, and then we can put in our best known plans to date with different levels of complexity for each of those.
Yeah, I think it'd also be interesting to make sure we're dividing up the approval process well. So, like you say, there is going to be some environment dependent aspect, right? Like if you're running in Google versus Amazon versus bare metal versus whatever, like, did this request come from this node? Can be verified a lot of different ways, and that's very environment specific. The categorization that we were talking about earlier, like, is this a request by a node for a renewed client cert or by a node for a server cert? Like, that categorization can be done independent of environment. And so trying to avoid duplicating the work among all the cloud providers to do that categorization and let them focus just on given this CSR and maybe some other data associated with it, thumbs up or thumbs down, did it come from this node? Trying to make sure we can divide that up well would be helpful in reducing work.
Yeah, I think that's right, because there's a limit to how many of these environment-specific plugins we are going to develop and own, and I'm not even sure how many would get embedded, right? So
I don't know if that's I don't know if that's the new condition. Like right now we have the approved, rejected, I guess, conditions.
yeah.
Is there another condition that says, like, did someone verify that this request actually came from this node? Maybe, and maybe that's like a separate condition, and both the approved condition and the verified condition have to be present. I'm not sure.
So I think what you're describing is a lot of implementation detail, and you have to step back and say, what are the attack scenarios I care about, right? Why am I rotating these node certs? And if somebody has leaked one or compromised it, allowing someone who has compromised it to arbitrarily renew it is, of course, not going to help your security properties. So just because I had a search for the node doesn't mean I should always forevermore be able to renew it. And therefore, I think you have to have some more claims as part of that, like, node re-verification process. If you really want them to expire after 12, 24 hours, it has to be revalidated that it really is the kubelet on that node, not a container on the node, not somebody who's leaked it and exfiltrated it somewhere.
Yeah, I think what I was trying to sort of get across with bringing this up is not necessarily about how we might do it on other providers, but more that the idea was that we would sort of have, a lot of different approvers. And the reality is that we kind of only have one today, which is this one bootstrapping approver. So as we are adding features like the certificate rotation, like this PR, if it doesn't work with the bootstrapping, the one approver we have, then it's kind of, it's hard to sort of get this in. Whereas it would be very, very helpful if we started possibly exploring what an approver looked like for AWS and, ironing out those details over there and seeing if the API is correct or, has the necessary features that we need to go implement more. But I think that the reason all of these sort of, we're adding more and more to this current one is because it's really the only one that we have.
Yeah, I don't think the current one is intended to be long-term for anything. I don't really care about verification. I just want to auto-approve things. So I agree, we should not keep packing more and more onto it or expect it to be around long-term.
Here's a question. Do we have a roadmap for this? I mean, it sounds like if we had a roadmap and we knew where we were going, it'd be like, yes, this is a consensus that this is on it or not, versus trying on a point-wise basis to justify things.
When the API was originally designed, we had discussed how approval would actually happen. And we had discussed it in terms of having separate controllers that could be managed or created by anyone with the right API access to provide the signature and the result. And so the API was based around when you create it, this is the assertion of who submitted the request to the server. Use that however you will to do whatever verification you wish to do to determine whether or not you will sign it. And then once you've signed it, attach the result in the status, or if you've denied it. And so continuing to add on to an existing controller is odd.
I love the idea of making these separable controllers that people can prototype outside and like write your code and do it.
Yeah.
Like the right model.
And so that was how the API was originally designed. I remember that in review comments as we were dealing with it.
Is it worth codifying some of those things into like a roadmap doc rather than tribal knowledge or review comments on one PR? I don't know. Like, this is a SIG structure question, maybe.
It's probably good to clarify out in the tailless bootstrap feature, which is still tracking this. So splitting the approval aspects out from the current controller. So we have a signing controller, which we already have, and then an approval controller, which we currently are running together. And this is adding more approval cases. We probably want each approval case separate.
I think that there's two pieces of this puzzle. There's the how do we actually create a way for the kubelet to add extra identifying information to a CSR that may be domain specific or environment specific. And then there's on the server side, how do we have a pluggable model for something to evaluate that extra proof and use that to make decisions in terms of whether to approve the CSR or not.
Mike, you want
We're just
to add
looking
those
at
add those to the feature?
What's I'm sorry?
Yes, I can. I'll try to extend that. I was unclear. Did you mean that the group approver in its current state is not expected to stick around long term, or do you think that even with the extension of subject access reviews for specific kubelet uses, if we had like a node specific approver that did some subject access reviews, would you see that sticking around for longer? Or
I mean, I think a controller that is based on permission checks is a reasonable thing for some clusters. I would want it separate from the signing controller. Like running the signing controller is just, give it a signing certain key and say sign anything that's approved, and that's broadly applicable. A controller that does permission checks might work for some clusters, might not work for other clusters. I would feel weird telling someone, oh, you got to run this cluster and it'll sign, and maybe it'll do permission-based checks, but you can disable that like this particular way. It's much easier much cleaner to just tell someone, oh yeah, run the signing controller if you want to sign, run the permission-based approving controller if you want to approve that way, or run some other approving controller if you want to approve based on TPM or whatever.
Maybe this is out of scope, but why an approver versus as a controller rather than a webhook?
So because those things are not necessarily synchronous operations, so requiring something to go out to the node, and you might have a human approval case, or who knows what processes are involved in certain approval.
But that's not to say that a webhook should be out of scope, therefore. Or we could have a webhooking controller. This is one of those latency issues where you also don't want it to take 3 minutes for a node to start up. And so making sure that we have ways of pulling down tail latency eventually.
I mean, if you have a controller that's watching, that's the same pattern as the scheduler. Like having node startup be on the same order as starting a pod doesn't seem crazy. If that mechanism's broken, we're kind of screwed. I mean, you could write this in Bash.
Please don't.
You could.
Mike and I will come hunt you down.
We know who.
I'll do anything in Bash.
Yes, you would.
I think that the
okay, but seriously, I think on the kubelet side, and this is something to actually look at the sum totality of this feature. Is there a way where we could have like a .d file where you drop in a program similar to like CNI, where it says, okay, as we actually are asking for a cert, we're going to run the programs in this directory and give them a chance to modify the CSR in some format before it gets sent forward, right? So then that would be a way for when you're running on AWS, that's the thing that grabs the identity document and somehow jams it into the CSR or something that gets controlled with the CSR and it gets forward. So I think we should think about both sides of this.
I mean, however we're doing the cloud provider stuff, the kubelet already makes cloud provider calls, right? So however we want to factor it, having a cloud provider or environment specific way to inform not just the CSRs, but possibly other types of requests. Seems to make sense.
But the idea of cloud provider is it assumes a level of consistency of cross environment that's really not there.
Yeah, that's possible. Yeah.
Right, because like I have a TPM on my machine, right? Is that a cloud provider? Do we now have a TPM cloud provider? That just doesn't seem to
a bare metal cloud provider.
I think if you treat it at TPM level, maybe, but for like this, does your cloud provider think this is actually the kubelet would be a reasonable abstraction, I think. So from a reasonableness standpoint, maybe we could debate which one is 5% more reasonable than the other and closer to perfection, but I don't know.
There's also going to be
who has been looking into the verification stuff for the TPM stuff? Mike, you said someone on your team? Or?
Yeah, this quarter, I know Jacob Beecham and Chris Rousey have been, and Jacob Simpson have all been looking at that specifically for GCP. And we have discussed exec-based plugins. There's going to be a lot of variability in what is required. Some are going to be mains that run in like, less than a second, and then some are going to be need to start up web servers depending on, I guess, the approval process. So, and then there's the distribution of these exec plugins that was discussed and kind of adds a bit more complexity. If you guys want to talk about some plugin mechanism that the Cubelet can call out to, I can definitely open an issue. I don't think there's been a central point of discussion for that yet.
It's definitely separable from the main flow here. So like, it's in the soup here, but I don't, it's not the top of the
Sure.
plate. Yeah.
All right, so I made a few notes about having to document how I actually want this flow to work, and it sounds like Mike Denise is going to describe an exec-based flow for us as well, and that issue is just, it's related, so I think we've covered that as well. Is there anything else that we want to talk about? You have, what is Spiffy?
All right, so all this stuff that we've been talking about how do you actually verify nodes and workloads and generate certificates and rotate them? We've been talking about this in the context of Kubernetes, but it's actually a more generic problem than that. And so this is something that I've been talking about forever, and there's a group of people that, some of them sort of in the Kubernetes orbit and some people outside of the Kubernetes orbit that are starting to get more and more serious about this. But the idea is, can we take all of that identity control plane stuff? Who has access to what certificates? How do we serve them up? How do we rotate them? How do we verify a node and then use that to bootstrap other types of trust? Can we break that out into a system that actually is runs beside and outside of and underneath and works with Kubernetes? And so now, if we had something like that, then the Cubelet would defer to Spiffy for getting its identity and its certificates. And then that same API or mechanism for how the Cubelet gets its identity could then be used for workloads running inside of Kubernetes, so that they could then use that identity to talk to each other. So there's this, and it sort of breaks down into three problems. Number one is, how do we encode identity into a certificate? How do we verify that certificates? By encoding identity, it means just coming up with some URN type thing that we can put in the common name that everybody, or subject alternative names into the SAMs that everybody can agree upon. Something that is a global namespace that everybody can come down to. How do we verify that? So the problem is not just distributing client certificates or server certificates, private certificates, signed certificates, but also roots, right? Because right now we either pass in a bundle of roots to everybody, and now there's a separate problem of how do you actually update that bundle of roots that everybody's relying on. And then there's the question of which roots apply to which parts of the namespace. So it's, how do we encode this stuff into certificates? How do we deliver those certificates and those identities to the workload? And then a reference implementation of this that sits outside of any one orchestrator or system like Kubernetes. And then finally, how does this work with Kubernetes as sort of an outside controller, such that you could, by convention, as part of like maybe an admission controller, say, or, built into the service account, say, we map a service account to a Spiffy ID. Every pod that's launched with access to that service account then gets a certificate that lets us act as that service account, not just to the Kubernetes API, like with the JWTs that we have now, but also between user services that are running within a cluster. Because right now, service accounts are useful in a star topology for everybody talking to the API server. They are not useful for workload A talking to workload B.
So this looks like a pretty involved pretty involved doc. I am interested in reading it. Being able to talk between pods with a positive assertion of identity would be great, but I'm not ready to have that conversation now, given the scope of your doc here. So
it's been floating around for a while. There's a lot of discussions. I think one of the goals out of this then is not just within a particular cluster, but between clusters, between different orchestrators, between orchestrated containerized workloads and non-containerized workloads. And then also, given the right saturation, this could be used across the internet for talking to web services in general. So I just wanted to this is in some ways, I know that the group of people that have been talking about Spiffy includes some of the Docker folk that we're supposed to talk here today. So this is one of the things that they've been looking at as they think about how to solve this problem. This is inspired by this system at Google called LOAS. And I know that some of the Istio folks have also been looking at this in terms of if the workload itself doesn't want to consume and use those certificates, can this be done in a sidecar proxy then also? So I just wanted to get the word out there because this is starting to be an area that a lot of folks are starting to look at and invest in. I think within Kubernetes, this problem that we're solving with how do we bootstrap and actually maintain a connection between the kubelet and the API server, we're going to repeat that for all the other components of the control plane. And then as we move to things like webhooks and sort of more distributed things, sort of like, external admission controllers, like every time we boot up another one of these things, it has a handful of flags, which are TLS this and TLS that, and then you have to configure both sides of it. And I've seen that customers have an incredibly hard time creating, managing, and specifying the right certs across, dozens of flags. It's probably not dozens yet, but it'll get there if we continue down this path. So how can we actually reduce this down to the point where it's like, things run in a Spiffy-enabled environment, and then when you say so-and-so is allowed to talk to so-and-so, it comes down to a simple string comparison.
Like I said, it definitely seems like something worthy of research, but that research needs to be done for us to have an intelligent discussion here.
Yeah, I've been talking about it a lot. I've been hesitating pushing it in the Kubernetes world just because it hasn't sort of hit in a certain critical mass. I think we're getting there. I'd love to talk to anybody about this or do the right intros if folks if this piques their interest.
Yeah.
Hey, Joe. So this is definitely piques my interest. So I'm Greg. And I'm at Google on the Kubernetes team. So one of the use cases we've kind of been running into is basically secrets and interacting with external secret stores. And so having some sort of identity that we can use, to talk to services like Google KMS, Amazon KMS, Vaults, etc. So some sort of externally recognized identity is, a thing we're bumping into right now. And so we've got in kind of the secrets world, we've got some short-term kind of encrypted database and Jordan's work to kind of reduce the access that nodes have to all the secrets. But sort of in the longer term, we want to set people on a really easy, simple path to have an identity that they can use to talk to external stores. And so I've been talking to Wenchang, Istio people a lot, and also to LOAS team internally here. And I think we're sort of moving in a direction and getting a design kind of in this area is something that I'm actively working on. So we'll definitely be talking to you about that.
And I think there's this is not Heptio's main thrust. This is kind of my personal thing that I push, but I can introduce you some other folks who are really investing in this deep. One of the realizations that actually came to this is that I looked at HashiCorp Vault, and then from my experience at Google, I'm like, there's really nothing that maps to Vault, at least back then, There was, some systems that were explicitly not supposed to be used for production certificates. And then the question was why? Why did Google not have to invent something like HashiCorp Vault? And my takeaway from that is that because LOS existed, there was so little need to store credentials for your MySQL database, right? Because Bigtable knew how to consume LOS credentials natively. And so the realization there is that a large percentage of the use of secret stores is to really act as an identity translation service, right? So people put a secret in there, they present themselves to the secret store with one identity so that they can attain a proof of a different identity. And so it's kind of like a Kerberos ticket vendoring system in some ways, but in a more generic way. And so the root of the problem is that we don't have a sort of lingua franca around identity. And so can we start establishing that? Secret stores aren't going to disappear anytime soon, but we can at least start driving some commonality around how do we create and distribute this type of information and start creating an understanding and a network of identity proof.
Yeah, I think it actually unlocks a lot of doors. So once you have that, I mean, it's a very internal to Google. It's basically dial tone for kind of stuff that you run internally, right? So you have this identity. It's just there and transparent, ready to use. And I think we'd like to have something like that for Kubernetes, where your identity is just it's there. There's not a huge amount of effort, and you can use it to talk to external things.
Yeah, that's the idea. And if you actually look at the presentation that I gave about a year ago at GlueCon on this, there's a slide on there that says it's dial tone. So that announcement. And the beautiful thing at Google,
maybe that feedback has come around to me again then.
I think the beautiful thing is that from the developer's point of view, they get a secure by default environment without actually knowing that they're getting it. It's really a pretty beautiful thing. So that's kind of the hope out of this. So I just wanted to get the word out there. I think, folks are starting to light up around this stuff. So feel free to reach out to me and we can have some conversations around that.
Yeah,
All right.
I'll definitely do that. Yeah.
So I will be reading that as well. I think that closes us off for today. Looks like we covered everything. It's a good stopping time. I'll see you guys in a couple weeks, and see I'll be following up with Jordan and probably with Joe at some point. All right. Bye, guys.
Bye.